Hello guys. So today I'm going to cover this event loop topic, and in event loop, like many people actually have this problem, like to understand the flow about the event loop. And if I talk about the set timeout and how the promises works, right? It's quite like some people face the problem to tell the how this works, and like they and many people actually have the problem to understand the flow. Okay, so I'm going to try my best to explain this topic. Okay, and let's begin with this event loop. So before going deep into event loop, I just want to connect this flow with the previous video where I have explained this JavaScript engine, and I covered this the JavaScript engine phases. And I'll just give some brief, and then we'll move on to the next phase. Okay. So, so the first phase I covered is parsing. So in parsing phase, I have covered how your file uh, executes and how your file comes inside the JavaScript engine, and then how it is parses to the abstract syntax tree level. Okay. So the next phase was compilation. In compilation, the abstract syntax tree was the input for the interpreter, and then I explained how the interpreter, profiler, and compiler works together to get the optimized code for your browser. Okay. So these are the 2 points which I covered in my previous video, and today I'm going to start about the third stage, which is the execution step. And in execution, I'll be talking about the point here, the call stack, memory heap, and your browser, how it executes the code. Okay. So, so this JavaScript runtime environment is important for each browser, whoever is like going to support this overall JavaScript execution. Okay. So this JavaScript runtime environment includes your JavaScript engine plus this web API and event loop and your Microtask queue and the callback queue. So these are the main components which I'm going to explain it. Okay, so let's start with the call stack and memory heap. Next thing is call stack and memory heap. In call stack, this runs based on the single threaded concept. Okay, and that means we have one thread and one call stack, and your code will be executed one by one. Okay, so to execute any JavaScript file, we first thing your GEC should be present in your call stack. This is very important to understand. Okay, so here this GEC, this is global execution context, where we have two main objects which is global object. This is actually global this, and the second object is the this. Okay, and here these are the two objects which are main responsible to provide you the first level of the context for your whole file. Okay, so even if you do not have any single line of the code in your file, and when you start executing that file, this context must be available to just to start anything or to start executing your JavaScript file. Okay, so we will see that like how it comes into the picture. Okay, and here each your block represents mainly the one function in the call stack. Okay, and inside each function, if you have any memory you need to allocate for any object, that will be provided from the memory heap. Okay, and in memory heap, all these blocks which represents the memory blocks. It is not mandated to have in the contiguous, but it may be some blocks here and there will be distributed. And also I am going to talk about here the garbage collection. Okay. So garbage collector, it is continuously looking your memory heap, and if any object do not have any reference, then it will mark it, and in the next cycle it will sweep. So this is mainly works on the concept of mark and sweep. So after marking in the next cycle, it will clean that memory. Okay. Next is memory leak. I will also just touch like few points here to understand like where are the chances we, when we write the code, we leave that some code and that leads to the memory leak. Okay. So here if you talk about in your global environment, if you have your variables, you are keep on like creating these variables, this will be like sometime it will be present in your global level. So we have to be like careful to avoid actually such kind of the variables, and try to have all the variables inside some scope, either inside the function or some block level. Okay. And in the same way, we have the set interval function. This is also sometimes leads to the, if you have defined this in the global level, and if inside the set interval, if you have any object which is referencing to the some memory, then if you are not clearing that interval, then also it leaves some time to the memory leak. The third thing, which is I have seen in multiple places where we bind the event listener. So when you bind this event listener, we also take care about to remove the event listener as well, because these are present in the global level and which sometimes leads to the memory leak. Okay. So next thing which I want to just show you like how this in the previous slide, how this global execution comes into the picture, and we need to see in the browser itself. Okay. So here in browser, I just wrote this debugger only to stop our execution here, and we do not have anything in the file, but I just want to show you how is this GEC comes into the picture without even if we don't have any code in the file. Okay, so let's run this file. Okay. When I'm running it, it just stops here because of the breakpoint. And then if you check this call stack, what is this? This is your GEC. Okay, and I said here we have two objects. Now let's check those objects. Global this. Okay, global this is nothing but this is your window object, and then next is the this object. This is also here we have as the window object, and both are actually same. Okay, so global this is it is also also present inside the node environment as well. Okay. But when you run this in the node environment, the window will not be there because this window object is only for the browser. Okay. So next thing is to understand more into CallStack side. I have just this snippet of the code which I just copy pasted here. To let's execute this and understand like how it's going to show in the CallStack. Okay, it was not attached. Okay, let me attach the breakpoint. Run this. So the first thing is like it started from the print area because this is where it found this to call this print area function to perform some area calculation. Okay. Now let's go inside this. So at the first moment when it starts execution, it has this global context, global execution context, and then I'll go inside this. Then it will come to the print area part, and inside this we have one more function to execute. Okay. And then inside calculate rectangle area we have one more function to call, and that is multiply function. So here now if you see your call stack, as we started from the global execution context, the print area added into the call stack. Then from the print area we have one more function, calculate rectangle area. This is here now, and then finally it calls the multiply function. Now this multiply function had only to return the multiply width and height. So when it runs that line of the code and return that calculation, it came inside the calculate rectangle area. So this multiply function popped out from the call stack. Now it is inside the calculate rectangle area. And then when it return from here, this function will also get popped out from the call stack. Okay. Now it inside the print area we got the area calculation, and now it will print it and then will come out of this function as well. So this function will also get popped out from the call stack. Okay. Now we have last is global execution context. So if we run it, this will also popped out, and the whole program will get executed that way. Okay. Okay. So next thing to talk about in JavaScript runtime environment is the event loop. Okay. So in event loop, this is mainly consists of your call stack, callback queue, and web APIs. Okay. So call stack I have already talked about. Next is web API. Web APIs are APIs which is provided by the browser, and we have many APIs like set timeout, fetch API, and DOM API, and we have geolocation API plus local storage, session storage, many other APIs as well. All these APIs works in a asynchronous way. Okay. And I'll go into when I'm going to explain the set timeout how it works, I'll be like giving more deeper like what is the role of this web API when it comes to the execution level. Next, I'll just give brief about the callback queue. So this queue is like basically is a queue for the callback functions. So when any function gets executed or they finished from the web API, they get pushed into the callback queue. Okay. So this callback queue maintains your all the callback function here. Okay. Next is Microtask queue. This is specific to the promises and mutation observer, where it maintains all the callback functions which are finished from the web API and pushed to the Microtask, but this is specific to the promises and mutation observer. Okay. So we need to understand this some simple example about the set timeout, how it works, and then I think we will have better understanding about the web API and callback queue and Microtask queue, and how the event loop comes into the picture. We are going to understand better by this example. So To understand better this CallStack, web APIs, and callback queue, I am going to run this program. Here you will see like how this how this click event is going to work and how this set timeout. It will just show like very proper way here. We can observe this. Okay. So I'll just rerun this. See this. The timeout came and this timer is start for this 5 second here. When it finishes it will callback sent here, then executed, and then now we have this first this event listener here. Okay, so here if you have observed this, I'll just rerun this to observe this again. Here this console.log comes immediately the call stack and it will get executed immediately. Then the set timeout comes here inside the call stack and then immediately popped out from here to the web API. This web API maintains this callback with the timer of 5000 milliseconds. And here it will wait for the 5 seconds, and when the timer expires, then web API will send this callback function to the callback queue. And from here, this event loop is continuously checking this call stack. Whenever this call stack is free, it will take this first function in the callback queue and will push to the call stack for the execution. Okay, so just watch it again. Okay, now here this is still click event is still there. So when I click this, just let's see the execution. Here we have the set timeout timer again for the 2 seconds, and when I click on this button, it will push the callback, this set timeout callback inside the web APIs for 2 seconds to wait this, and then it will get executed. So let's watch this. Okay, so this is like overall picture here. This event loop is responsible to take the callback function from the callback queue and push to the call stack, and this will like keep on watching to the call stack. Whenever it's completely free, then only it will take the your callback function. So this is like set timeout and promise. This is very important to understand with this example, because this set timeout, when this gets executed, so web API send this callback to the callback queue. But for the in case of the promise, the callback will be sent inside the Microtask queue. And here is the we need to understand this callback queue and Microtask queue. Okay, so with this example, if you see it, the first console.log will get pushed inside the call stack and it will be printed immediately and will be popped out from the call stack. Next is set timeout. So set timeout will be pushed to the call stack, and the callback function here will be pushed inside the web API with no delay or the zero delay. That means it will go to the web API and immediately will be pushed to the callback queue. This callback function will be pushed inside the callback queue. Then next here, this promise also, if you see, so here there is no delay in the promise as well. It will get resolved immediately. Okay, so when promise dot then will execute, it will immediately pushed inside the call stack, and this callback will be pushed inside the web API, but here we also don't have any delay. So this will be pushed inside the web API and immediately will be pushed into the Microtask queue. Now we have two callback for the promise. One is this one and like this is again. So the two callbacks will be pushed inside the Microtask queue. Okay. Then this console.log will anyhow it will get printed immediately whenever it's going to execute this. So now to understand this, I'll just show 1 second. So here, now to understand both of them, from the set timeout, the callback is here is waiting for the event loop. Also, the callback from the promise, we have two callback, right? So both of the callback is also waiting inside the Microtask queue. Now the question is event loop, and both of the callback either is from promise or is from the set timeout, because we do not have any delay. In that case, both the callback immediately will be pushed from the web API to the both queue. Now event loop is checking this call stack. This is free. Now event loop is to which callback function he should pick the first. Okay, because in Microtask queue and callback queue, in both places we have available we have availability of this callback functions. So Microtask queue is given the higher priority comparing to the callback queue. So event loop first will execute the first callback from the Microtask queue, and it will push here inside the your call stack. Okay, and then this will get executed and will be popped out from the call stack. Okay, so this is executed. Then second, again it will take the second callback from the Microtask queue and will push to the call stack and then will execute this. Okay, so till the time we have all these callback function inside the Microtask queue, the priority is given to Microtask queue. So all the callbacks first will be executed from the Microtask queue, and after that it will look into the callback queue and will execute here. Okay, and then it will execute the callback function from the callback queue, and then it will popped out from the call stack. Okay, so here to understand, because at the same time we have the callback function available in Microtask queue and the callback queue, and the priority is given to the Microtask queue. Okay, now we need to understand here. Let's see. I have this here. This was the original situation here. Okay. So here we have the priority, higher priority for the Microtask queue. So let's say if you have the higher priority, that means every time if any of the callback function available inside the Microtask queue, this is keep on waiting, right? Let's say here we have some situation when I'm executing the first callback, then it again produces one more callback. Okay, so if that is the case, the first callback from the Microtask queue will be executed, but is simultaneously is also produces one more callback in the promise, and which comes inside the Microtask queue. Okay, so in that way, the first executed, then second executed, then fourth is executed, and this is the callback queue. This function is continuously like waiting for the execution to be completed for the Microtask queue. But here again, this when the 4 is executed, it again produces one more callback inside the Microtask queue. If this situation continue to keep on adding one more callback function inside the Microtask queue. So with this situation, this will not get the chance to get executed. And this is called the starvation concept. Okay. So this is like further, if to understand other concept, deadlock and live lock and the starvation. If people are interested, please comment out in this video so that if more people are interested to understand how those things are getting handled, I am going to create the one more video on that topic. But this is like here, I wanted to just give some more depth how is Microtask queue and the callback queue works here. Okay. So here there are like few questions which people ask sometime. What does set timeout 0 means? Why we use this 0 here, right? So set timeout 0 when we add it because it like we are not passing any delay here. That means sometime if we want to execute our function in the asynchronous way, right? Like let's say you have some array of like 1 lakh number inside that array and you want to print out all those, right? So when you run that big number of array is going to block your flow in the execution and you will not be able to do any action till the time that array execution is not finishing. So to avoid those situations, we use this set timeout so that whenever it executes any number, it will send your callback function inside the callback and then it will be executed. So your execution in the browser will not get blocked. Okay. So this is the one thing which I wanted to explain. Then second is like sometimes we think if we passing the set timeout as some delay, let's say here 1000 millisecond. So does it mean it is always going to be executed just after 1 second? So the answer is no, because when it is 1000 millisecond will be counted inside the web API, and web API, when the timer get expired for the once 1000 millisecond, then this callback function will be pushed inside the callback queue. But it is based on if we have any CallStack functions and the CallStack is not free at that moment. The callback queue function have to wait to get the availability from the CallStack, and then only the event loop will pick this callback from the callback queue and send inside the CallStack for the execution. So this is not mandatory that you have to your function will get executed immediately after the 1000 millisecond or whatever the delay time you are giving here. Okay, it is based on the circumstances of the CallStack availability. Okay. Third question, I answer this, but just read out this question only. What will happen when one promise callback create new promise callback? Right. This is the situation when which I was explaining in the when you have one promise and that promise is creating the new promise callback. So with that case, it is creating the sometime your callback queue has to wait till the time your microtask queue is not finishing, right? So this situation called your starvation. Okay.
Thank you for watching this video. If you like this video, please like it, subscribe it, and press the bell notification to get the notification for the upcoming videos. And below is the WhatsApp group. Here you can join if you want to get the daily updates. Thank you.